Okay, so what we then have is we now have the tools needed to tackle this. The problem we need to solve is that when x is equal to unknown, you have two lines of length 4.1 centimeters on this triangle, and we need to know what that unknown x is. And so what we can do is we can utilize this formula. A is equal to half AB sine C. And let's tackle this first by suggesting what have we been given. So we have been given an isosceles triangle with lengths of 4.1 centimeters, angle x which is unknown, and an area of 14 centimeters squared. That wasn't stated in the beginning because for various reasons I wanted to discuss area generally, so perhaps that gave it away. But overall, we also have been giving an area of 14 centimeters squared, which with that area, you then can work these things out, and I shall express how that is done. What do we know? Well, we know that A is half AB sine C. The area is 4, so I'm going to plug that in there. We also are aware, let's reduce the size of this so I can start doing the point. We're also aware that the C in this diagram is the angle x. So what we can do is we can say rather than C, we can put a lovely x in there. We've already put our 4 in. What are we missing? We're missing our two sines. Well, first of all, let's multiply both sides by 2 to get rid of this fraction. We got 4 times 2 is equal to AB sine x. We don't need that 1. Multiplied by 1 makes no difference. And so we're at this stage where 8 is equal to AB sine x. What is AB? A and B are both 4.1. 4.1 multiplied by itself is 4.1 squared. We can then divide both sides by 4.1 squared to give us 8 over 4.1 squared equals sine x. I can then do sine to the power minus 1. In other words, I know I have this information. This would otherwise be the opposite side relative to the hypotenuse side if it were just about sine x. But for now, not to cause that complication, we just are aware that sine x is equal to 8 over 4.1 squared. We're aware that sine x is equal to 8 over 4.1 squared. So what is the x? Well, to do that, we do sine to the power minus 1, 8 over 4.1 squared, and you'll end up with an x of 28.42 to 4 significant figures. And so when you consider this, that should be 28.42 degrees. That seems about right to me. Now, that is not the final answer. What that represents is if we have an angle of around this angle in here, if that angle was about 28.42, then you'd have something like 4.1 squared, about 22. This length would be around 22-ish in length there. And this length of the this is the denominator, so that's 22. 22 would be the opposite. No, I was correct. 22 would be this length here, the hypotenuse, and the opposite would be about 8. And please be aware that this diagram is not to scale because that does not look like the case. I don't want to cause, I'm just going to make not to scale there. So, and what I will do just to drive this home is I'll add that information. It is as if this is around 8 and this is around 22. That is what this is representing. And the angle in here, theta, is 28.42 degrees. Now the question is there another circumstance where you would get 8 over around 22 or 4.1 squared? In fact, we'll keep this at 4.1 squared in order to not cause issues. That 4.1 squared is, let's put it here. So this is about 4.1, like so, squared. So that's what I'm trying to say. This length is about 4.1 squared, which is around 22. This length is about 8. Now, is there another situation in which you could get that same relationship where this is around 8 and this is around 22? Is that the case? Well, the answer is yes. Another place that you can get it, if I was to take a line here and a line here, then in these circumstances, let's take one more line and just go straight down there, the relationship between, let's get a darker, completely dark, the relationship between this black line and this pinkish reddish line is the same, because that's 4.1 squared, of course, is identical, and this is 8. So there is another position in which you can get this relationship of 8 and 4.1 squared. There is another situation, and the answer as to what that situation is when the angle, if I get a little bit larger for this, let's get to like 20. The angle, instead of being theta, rolls all the way around to there. That is when you can get it. I'll do that again. The angle, rather than being 28.42 there, instead, I'm going to suggest that this angle all the way around to here will produce the same, because it produces a hypotenuse that's the same, and the line down to the axis is also the same. So it should also produce the same outcome. So how would that look? Well, how is to produce a triangle to make that occur? Bear with me for one moment. I'll be able to produce this quite quickly, perhaps. Then it would be this. Something in which I'd have a triangle that inside itself manifests that angle, like that. This line here is not exactly the length it needs to be, but I'm just trying to illustrate to you that an angle that includes this black angle in here will represent the same relationship between sine, because this will be of length 22-ish or 4.1 squared, and this line down, which is its height, right? Remember that line there is still its height, and therefore is still its opposite. And let's make this clear, because I don't judge. I've made that clear enough. This is still the height. If I can write that in, it might be best. This is still the height of that pink triangle that I've just drawn. So it is still the opposite, or its height there. And remember, that's where that side came from. Then this angle that's producing this pink triangle should be able to manifest the same output, the same relationship of 8 to 4.1 squared, opposite to 4.1 squared. Then, and thus, as a result, we should still produce a situation in which you'd have an area of 4 centimeters squared and two lengths of 4.1 centimeters. Like I said, this is not the correct length. It should be equal to this, but in fact, I might need to do that so that things seem more peaceful. So that is to say, imagine, let's finish this off, that length. Let's do this length. There you go. And this one, which has a height, triangle height of this, which is the same as 8. There's no difference in this, 8. This length here is the same 4.1 squared. So is this 4.1 squared? So let's say 22. And this new angle in here, will produce the same relationship for sine. And what is that angle? Well, that angle is, if I was to try and make it clear by using a different color, this angle, like so, is the identical to this theta in here. That angle is the same as this angle there. So what is that? Well, this one here is 180 degrees, because it's all halfway around a circle. Take away this angle, because they're identical triangles. This triangle is identical. This triangle in here is identical to this triangle in here. And so the angles should therefore be the same. So what I would do is I would say, okay, if this x is 28.42, then we can finish off by suggesting that this angle in here is 180. If I get this correct, 180. It seems to my numlock was not off. 180 minus 28.2, so plus we'll say plus, you'll need an answer of 180 minus x, which will be the equivalent of 180 minus the 28.42 that we have. I would not use 28.42 because it's to 4 significant figures. I'd literally make sure I take this whole thing, sine to the power minus 1, 8 over 4.1 squared, and do 180 degrees, take away it, to produce my answer for that second triangle. So there are 2 solutions, and that is why there are 2. The first solution being relatively easy to produce. The first solution is the angle for this. The second solution is the angle for this black line in there. Thank you very much.